All right, unit 9. Just FYI, like these are not comprehensive. Like, I wish we had more solving. I wish we had more unit circle stuff, triangle stuff. We haven't really had a comprehensive set. I think the rationals and our exponentials were perfect in logs. There will be more other stuff that we're looking for in the calculator homework as well as the free response. So we'll be able to review everything eventually. What's the range? Remember, secant is a reciprocal of cosine. How do we graph secant? We start with the graph of cosine. Then we think about if we take the reciprocals of it. So like everything's same. Vertical translation, midline shift, amplitude, vertical dilation. Uh, Secant's reciprocal of cosine. We do cosine. Period. Don't care about. I don't care about the period because we're talking about the range. So I'm not going to bother worrying about the period. Rather, what I'm going to concern myself with is what happens if you take the reciprocal of these numbers. So this is y equals, in black, cos x. Y equals 4 plus 2 cos. Now, let's do y equals k. Thinking about this as 1, if we take the reciprocal of 1, we get 1. Thinking about this as being our 0, if I take the reciprocal of 0, I get undefined. Thinking about small decimals, again, this is not the ideal situation because you're talking about 4, but really you're pretending like this is our parent function. If you pretend like it's your parent function, this is going to make more sense. Wherever you have small decimals, flip them, becomes large numbers, and then numbers will become decimals, So it's like big things flip to get small, small things flip to get big. And this is why we can kind of see that secant will exist above y equals 6 and below y equals 2. And that's this one. And since it's just the range, we don't have to worry about the period or anything or where the vertical asymptotes are. Which one of these has a vertical asymptote? 4. I don't want to sketch them all. That doesn't make sense. But it's like vertical asymptote, we're looking for some sort of number over 0. So cosecant of 1. First of all, you don't know what the cosecant of 1 is. You do not know the triangle at the angle of 1. 1 being close to pi over 3. So the angle of 1 is very close to the angle of 60 degrees. But exactly what it is you don't know, so you don't know the ratio, so it's not this one. Cosecant of 4 times pi over 8 is pi over 2. Now, what's the cosecant of pi over 2? Well, let's find the sine of pi over 2. The sine of pi over 2 is 1. We're going straight up and down. Cosecant, therefore, is 1. So it's not that one. Secant of 4 pi. Well, let's find the cosine of 4 pi. Well, the cosine of 4 pi is the same as the cosine of 2 pi, same as the cosine of 0, because they're coterminal. It's 1. Flip it, it's 1. So it's not this. Secant of 2 pi. What the heck? I think the one on the left is what we were looking for, but he screwed up. Secant of 2 pi is also 1, because it's the same as cosine of 4 pi. If this is pi over 2, I think that's what we're looking for. Or pi over 4. Because then it would be the cosecant of pi. The sine of pi is 0. The cosecant of pi is like 1 over 0, vertical asymptote. So like I'm picking A, but after changing that 1 to a 4. I think that was the intent of the question, and that happens sometimes when we teachers make questions. All right, vertical asymptote, again, number over zero. So let's think about tangents values, or let's go straight to cotangent. Cotangent of an angle is an x over y, so it's the horizontal over the vertical. I want my vertical to be zero. So to have the vertical be zero, I'm looking at 0, pi, 2 pi, etc. So I want the cotangent of 0 pi, 2 pi. I want 1 half x to be 0 plus pi n. Multiply both everything by 2, and we got multiples of 2 pi n. So any of these multiples of 2 pi n, that is, let's say you don't do that. Just plug in all four of them, of course. And one of them will give you the cotangent of one of these horizontals. And boom, adjacent is -1, opposite is 0. The horizontal divided by the vertical. All right, vertical asymptotes, like multiple things you can do. Some of you love graphing, and you're like super comfortable with the graph of sine. So you're going to be super comfortable with the graph of cosecant. That's fine. That's fine. That's one way. Graph. The other way, figuring out when is cosecant going to be undefined. Well, when is sine going to be 0? That's when cosecant's going to be undefined, 1 over 0. Solve this equation. Okay, like when is sine 4x going to be equal to 0? What are the angles for sine at 0? Again, it's 0 pi, 2 pi, or multiples of pi, where k is an integer, divided by 4, boom, power 4. Including 0, including pi over 4. Pi over 4 is included in that, like, don't know why. Yeah, I guess they're thinking like pi plus pi. Like pi over 4 is included in that. This is unnecessary. You could have just said multiples of pi over 4. That's unnecessary. Cool. If you wanted to sketch, what would you do? You'd adjust the period of sine, 2 pi over b, that's pi over 2. So step that out, it's pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. There we go. Cosecant's a reciprocal of sine. Sine will go down because we have a vertical reflection. Cool. This is, I think, a little bit more work to do. Whenever you have a 0 flipped, it becomes undefined, a vertical asymptote. Whenever you have -1 flipped, it's -1. Decimals become large numbers. Large numbers become decimals when you flip them. And that's another way to say 0, pi over 4, and then multiples of pi over 2. Okay, same deal. I'm just going straight to cosecant 2x being undefined is the same as sine 2x being 0. Sine is 0 at 0 pi 2 pi. So that's going to be when 2x equals the multiples of pi, and that's going to be multiples of pi 2. Two more.